We have two wonderful speakers this afternoon, Dr. Charles Nelson, and then later Dr. Sam Goldstein. And we heard Dr. Sam yesterday. And my name's Bonnie Dykman. I'm from Madison, Wisconsin, where 2 days ago it was 2 degrees. So I'm happy to be here. Dr. Charles Nelson is professor of pediatrics, Harvard Medical School. If I say anything, it's wrong. Speak up. He's the research director, Developmental Medicine Center, Laboratory of Cognitive Neuroscience at the Children's Hospital in Boston. Co-author of EEG Complexity as a Biomarker for Autism Spectrum Disorder, 2011, BMC Medicine. A brief biological path. Earlier this morning, our first speaker talked about her path coming down the red line, traveling on the train in Boston, and I think that Dr. Nelson's path started in McGill in Canada, and so he kind of went down through the track of ice and tornadoes. McGill University, honors degree in psychology, University of Wisconsin-Madison, master's psychology, University of Kansas, PhD in developmental and child psychology, postdoctoral fellowship in electrophysiology, University of Minnesota, then 84, faculty on Purdue, then back to Minnesota. He must like the cold. He does. Then moved to Boston, where he's chaired the John D. and Catherine T. MacArthur Foundation Research Network on Early Experience in Brain Development. He served on the National Academy of Sciences panel that wrote From Neurons to Neighborhoods. His research concerns the effect of early experience on brain and behavioral development, especially those experiences that influence memory and the development of the ability to recognize faces. Dr. Nelson studies both typically developing children and children at risk for neurodevelopmental disorders. Today, Dr. Nelson will share with us how early adverse experiences, toxic stress, maltreatment, and neglect can affect a child's development, attention, and executive function. So, Dr. Nelson.
Out of curiosity, how many of you are teachers? And keep your hands up. How many of you are science teachers? Okay, that's really bad then. You'll be okay. Because the first little while is going to be some basic neuroscience before I get into the more interesting things. So here's the outline of what I'm going to do. I'm going to begin with sort of outlining some general principles of brain development. This will also set up the next speaker, I think, as well. Talk a little bit about the effects of experience on brain development. And then I'm going to talk about critical periods in brain development. And then I'm going to focus mostly on what happens to the developing brain when the expectable environment, which I'll define in a few minutes, is either missing or altered. So let's start. The brain begins to form about the third week after conception. It's a derivative of the primitive embryo, and I can do that in more detail later if you wish. But it begins, say, 3 or so weeks after conception. It's the formation of the neural tube. People in the audience who know about the public health campaign to take folic acid during pregnancy, folic acid is designed to prevent neural tube defects. Of course, given that the neural tube forms around the 4th week after conception, it's something you need to have on board before you conceive, which is something that some people seem not to understand. So 3rd or 4th week after conception, brain development starts, continues all the way through prenatal life. A lot of this is highly regulated by a certain number of genes. But after birth, much of brain development depends to a great degree on experience. And although genes supply the basic blueprint for the developing brain, once this blueprint is in place, experience exerts a very powerful role in fine-tuning the neural architecture of that brain. So the software then, if you want to think of it as a metaphor, is really the experience that writes on to this set of architectural plan that has been derived from a certain number of genes. Now, one thing we should think about at the beginning is, having established that brain development after birth depends critically on experience, we have to think, what kind of experiences is the brain getting? So we know that there are some experiences that are, or at least should be, universal to all members of the species. So that might include sensory input like seeing patterned light, or auditory input such as hearing sounds, hearing voices, It might include caregiving, because our species young can't take care of itself, so it depends critically on others taking care of the baby. And these experiences, of course, help ensure survival. Without these things, we won't survive. There's probably others that can optimize development. So instead of just caregiving generally, think of it as sensitive or consistent caregiving. So in 15 or so minutes, when I turn my attention to kids who grew up in profound neglect, they may have basic aspects of caregiving available, but the more nuanced aspects are maybe lacking. It could also be that they hear sounds, but you don't hear complex language, or you see sights, but you're missing some of the subtleties of sight. Now remember, this can work both ways. You can miss these things because of a problem in the brain, or the problem in your eyes, or the problem in your ears. So you can be born with cataracts, you can be born with a hearing impairment, and then you're missing these experiences. But what I'm going to focus on is the assumption that you're born with intact vision and intact hearing and intact sense of touch and the like. It's what's missing from the environment that's most important. In many cases, these experiences have to occur during a narrow window of time if development is going to be optimized and proceed along a typical developmental trajectory. And we think of these windows of time as a critical period or a sensitive period. Now, these terms have often been used loosely interchangeably, but there's probably a difference between them. We can think of critical periods when we think mostly of animal development, mice, rats, even possibly monkeys, because there the time scale is so narrow that if certain experiences are missing in a 2 or 3 day window, then that's it. The brain is inalterably impaired. In the human, we tend to think, at least certainly in behavior, of these things as sensitive periods because there's a little bit more forgiveness. So the analogy we might use, and I realize I can't do it here, is if I'm starting to, let's say I want to push open a door. No, I have a much better metaphor. I'll steal it from a student. This was in a final exam from a class I taught 2 years ago. We asked what's the difference between a sensitive and a critical period. And having just flown in from Europe last night and almost missed the connection, here's what he said. You go into the airport and you have a flight to catch at 1 o'clock and you hit traffic and you get to the airport and you get to the gate, and just as you get to the gate, the doors of the plane close and you're not going to get on your flight. And you do what many of us do. You cry, you beg, you complain, but they say that's it. That's the only flight ever going to that destination, and you're completely out of luck, and you're stuck in Boston for the rest of your life. A sensitive period, though, might mean with a lot of effort, you can eventually get on another flight. Maybe you'll be a day late, and you'll miss your talk. This has happened to some people, but with a lot of effort. So most aspects of human behavioral development that we're going to be focused on probably reflect sensitive periods and not so much critical periods. And I hope that is clear to everybody. If these experiences that are expected to occur during a sensitive period don't occur, and the sensitive period then ends, then the brain is affected in, well, certainly a short-term way, possibly a long-term way. And we'll come back to whether these problems become permanent or not in just a minute. Now, one key point to remember, though, is that experiences cut both ways. So if a child is exposed to adverse experiences during a critical period, then brain development can be undermined. But conversely, if they're exposed to good experiences, then you're, in a sense, more likely to have brain development proceed on a typical developmental trajectory. So here's a model of how this might look. And the laser pointer is not working, so I can't really, I'll use my cursor. So we have these genes in utero that sort of sculpt the initial brain. And then we have this period of time, what we call a critical period. And here's behavior in the adult. So prenatal all the way to adulthood. And this slice in time is what we're talking about as a critical or a sensitive period. And you can see that these things differ depending on the modality. My cursor's not working either now. Here we go. So you can see for sensory development, your ability to see, to hear, to feel, things like that occur much earlier. This is frustrating. There we go. than motor and language development, which occurs a little bit later, and versus higher cognitive functions. So, if a baby is born with cataracts, or a baby's born and their eyes are crossed, well, actually, many newborns have crossed eyes, but if by a few months of age their eyes are still crossed, if that is not corrected in the next couple of years, they will have a permanent problem in their vision. They'll have a problem with depth perception. They actually lose vision in one eye. That has to be corrected during that sensitive period. For language, it's the same thing. You don't acquire language in a vacuum unless kids are exposed to language. They don't acquire language. And that's probably shifted a little bit to the right in time. Higher cognitive functions take advantage of the protracted development of the frontal cortex, the prefrontal cortex, which means that the sensitive period there might extend into adolescence. All right? So for things like in controlling impulses or inhibitory control, planning behavior, cognitive flexibility, these are things that live in the prefrontal cortex right behind your forehead. And these tend not to mature until mid to late adolescence. And we might hear a little bit more about that in the next talk when you hear about traumatic brain injury. So sensory, language, higher cognitive functions all have slightly different time windows for sensitive periods. So just now, bear with me for a minute while I tell you a little bit about the biology of sensitive periods. At the neuronal level, where two neurons are communicating, it's the balance between excitation and inhibition, or what we refer to as the excitatory-inhibitory balance, that is really what controls the opening and closing of a sensitive period, and thus neuroplasticity in general. So, you may have heard this before. A 6-month-old baby anywhere in the world, I've just come back from Romania and Italy, so I'll use those two as an example. Kids in Romania only exposed to Romanian, kids in Italy only exposed to Italian. At 6 months, they can discriminate the speech contrast from any language in the world. But by about a year, they're only able to discriminate the contrast from the language that they're hearing. This is why native Japanese speakers, for example, who don't acquire English until much later in life, have a hard time pronouncing the R and L because they can't hear the difference between R and L. The reason we think this is going on is that the opening and closing of these sensitive periods, where you no longer can take advantage of experience, is being driven by this excitatory-inhibitory balance. So there's neurons that deal with excitation and neurons that deal with inhibition. GABA is the major neurotransmitter for inhibition. And this balance is what drives the opening and closing of sensitive periods. These molecular breaks operate early in life and regulate the closing of sensitive periods, and these breaks are probably applied because the system craves stability. Imagine if we didn't have a sensitive period, you would be subject to experience throughout the lifespan without the system ever really becoming stable. And that's probably the reason why we have these molecular breaks. So in theory, plasticity in multiple systems is something that could potentially operate through the life course, and our job is to figure out how to lift these breaks without causing the system to become unstable. So imagine a child who is born with strabismus, their eyes are crossed, but they never get their eyes corrected, but now they're 20 years of age. Is there a way, in fact, to make up for that, having gone through the sensitive period? And that's the latest evidence in neuroscience, which is there may be some promising things out there to do just that. So we know at the present time we can shift critical periods with experience and with drugs. So some examples. Going back to speech perception. Exposure to non-native phonemes or non-native faces. An example is if you're brought up in a Caucasian community, exposure to an Asian face or an African American face would be a non-native. During the first 6 months of life can extend the sensitive period for face and speech perception. So if you take 9-month-olds who between 6 and 9 months were exposed to a non-native speech sound, they will continue to be able to recognize or discriminate those speech sounds. We've demonstrated with faces that a 6-month-old can discriminate 2 monkey faces as well as 2 human faces. But by 9 months, they no longer can discriminate 2 monkey faces. But if between 6 and 9 months you give them a training and exposure to monkey faces, they can retain that. So the storyline then is if you wanted the ability to discriminate monkey faces, you should be raised by monkeys. You can see where that's going. We know on the pharmacological side, my colleague Takao Hench published this just a few months ago, valproate is a GABA-based drug often used to control seizures. If you take neurotypical adults who do not have perfect pitch and give them valproate and give them exposure to different frequencies or tones of sound, they can acquire perfect pitch. because what the valproate does is opens up that sensitive period and allows them to master that. The downside is he received 75,000 emails in 1 week when he published this paper by people wanting to know, how can I get perfect pitch? How? You take an anti-epileptic drug, which has some certain side effects, so it's probably not worth doing. Exposure to other GABA-based drugs or dark rearing. So there's work in Italy that has demonstrated that if you take rodents that have been born with crossed eyes, but then rear them in the dark as adults, you can correct their visual abnormality. But of course, the intervention isn't obvious what we would do in our case. We're not going to take a 5-year-old and raise them in the dark. Maybe a 15-year-old, but not a 5-year-old. So there are ways. And again, here's a practical implication of this, and this is my last line here. Again, my colleague Takao Hench and Janet Worker, who studies speech perception, looked at women who during pregnancy were on GABA-based drugs, often for a mood disorder like anxiety or depression. And it turns out their babies had shifted their critical period because the babies' brains were exposed to an unusual amount of GABA during pregnancy, leading to a shift in the critical period. So I give these as an example of the various ways that are right now on the horizon. All this work is in the last few years of being able to rescue a critical period. And why that's important is, imagine you've missed that critical period and development has gone awry. How nice it would be if later in development you can make up for that and correct that. But under normal conditions, most sensitive periods are closed within the first few years of life. So this slide illustrates the ability to change the brain decreases over time and why that is. So if you look in the red line, see if I can, here we are. This is normal brain plasticity influenced by experience. And you notice that most of the y-axis would be the amount of plasticity. Higher would be more. So you can see how much plasticity there is in those first few years. But then it starts to plummet after a few years of age. And then there's, sadly, this crossing point at around 30 or so, where it's mostly downhill. Some of you are aware of that. And then it continues to go downhill here. My mother's 88. She's sitting out here. She uses a computer, a GPS, a cell phone, and an iPad, not without calling me 10 times a day to ask what it's doing and why she takes it very personally. She thinks it's out to get her. And then she asks, how does that book get in my Kindle? Now, this is not an easy question to answer unless you want to go into binary code and digital information, and she doesn't get that. So I say, people smush it down and then they stuff it in there. And then she's very happy with that. Why do we lose plasticity? Because the metabolic demands to change the brain increase dramatically as you get older, and that's the blue line. So the sheer metabolic demands the brain imposes on, that is imposed on the brain to get it to change, increases to the point where it's very difficult to do that. And a good example of that is when you decide at the age of 50 to take up golf or to take up piano, having never played golf or the piano, how much effort would be involved in doing that? It may require you to practice 8 to 10 or 12 hours a day to have any degree of proficiency. Whereas if you start when you were much younger, think of Tiger Woods in golf. You see the pictures of Tiger Woods when he's 2 or 3 swinging a golf club. So it's just much easier to do things earlier because the energy required is so much less, the energy demands. So as I was saying a moment ago, the future can reverse critical periods in adulthood. And so what this is showing us is the immature brain, the plastic brain, and the consolidated brain. And what we want to know is can we shift the critical period to the right over time? Keep your eye on this. This is the future, but right now it's the future and not the present. So many elements of postnatal brain development adhere to the principle of critical periods. Most critical periods occur during a time of rapid brain development, the first years of life. After a critical period is passed, the effort involved in altering brain development becomes greater. Two big questions are, can we figure out ways to rescue a critical period? And are critical periods limited to the first years of life? For example, might there be elements of the transition to puberty that represent a second critical period, a second window of opportunity for correcting things? So with that background in mind, now let me turn my attention to two really depressing topics. What happens to the developing brain when there's a violation of the expectable environment? And I'm going to draw from the literature on toxic stress and profound deprivation to illustrate these points. So let's start with the levels of stressful experience. For those of you interested in this, the Center on the Developing Child has a website that has some very nice white papers that describes in great detail the effects of stress on the developing brain. So let's start with positive stress. We tend to think of stress in a very negative terms, but let's start with positive stress. A personal challenge that has a satisfying outcome. Think of little kids. The mastery of learning to crawl, to learning to walk, to learning to run, to ride a bike, any number of things. The result is usually a sense of mastery and control, healthy brain architecture, good self-esteem, good judgment, good impulse control. Then we have tolerable stress. So these are adverse life events, but they're buffered by supportive relationships. And the result is the same thing, coping and recovery, healthy brain architecture, good self-esteem, judgment, and impulse control. So the issue here then is that you have a genuine stressor in your life, but you have someone to buffer that. Maybe a child is sick and needs to spend some time in the hospital. Or a parent is sick and goes to the hospital, but there's another parent to help buffer the stress for the child when the other parent is in the hospital. So positive stress and tolerable stress are essentially equivalent in the effects on the brain, but what we're worried about is toxic stress. These are sort of unbuffered adverse events of great duration and magnitude, and the result tends to be poor coping and compromised recovery, increased lifelong risk for physical and mental disorders, compromised brain development, dysregulated physiological stress systems. So I think we can probably all think of examples of toxic stress. It could be significant maltreatment. It could be a death in the family. It could be the lack of basic resources like food and the like. I'm about to launch a big project in Bangladesh, and the number of stressors that kids are exposed to there is breathtaking. And we're trying to figure out how to model everything from infections and parasites to depressed mothers to lack of food. And so put this on a scale. So I don't want to imply that positive, tolerable, and toxic are non-overlapping, but I think what we should recognize, at least intuitively, is that when you get to toxic, we're talking about a different category. And what demarcates toxic from other is the lack of a buffering relationship coupled with the chronicity or severity of the stressor itself and the severity of the distressor. All right? What we're worried about is toxic stress for the most part. So what are some of the developmental issues that children face? We have low socioeconomic status. The children who grow up in poverty tend to have poor language skills, poor executive functions, and other effects on learning ability generally. And those of you who are teachers will recognize this if you teach in a low-income school or have kids in your class who are growing up in poverty. Chaos in the home is a big issue. It leads to greater helplessness, greater distress, poor self-regulatory behavior, obesity, elevated blood pressure, cardiovascular reactivity, lasting effects of lifelong adversity on body fat accumulation, systemic inflammation, and poor dental health. So there's a whole cascade of things that result from chaos in the home. Chaos in the home can be brought about by significant mental health issues on the part of the parents or just the general feeling of overwhelmedness. Chaos can be, I'm trying to think of an example where how many of you are from Boston? All right, I hope this is a safe example. We can think of chaos resulting from, imagine where it's a single mom, 6 kids, mental health and chemical dependency needs, and she's barely staying on top of things. Or you can have chaos in the home. We had in one of our study participants, the child has a very rare and severe genetic disorder, and the father dropped dead of a heart attack, and the mother was diagnosed with breast cancer. All right, so that level of toxic stress can be considerable, and it can lead to a lot of chaos in the home as well. So these are sort of overlapping things. Abuse and neglect. So impaired lifelong physical and mental health issues and shorter lifespan. And then we have this category we don't know much about, but we know how to recognize it, which are risky families, which are cold and unsupportive families. Many of the same consequences that I've talked about in the other case, but we know less about these families. These tend to be parents that are aloof and unsupportive of their kids. They may not be overly neglectful, but they're not available either. And it leads to some of the same consequences. So timing is everything. Different neural and behavioral. So rather than restate the question, what I'm going to do is take advantage of the question to do something I probably should have done a few minutes ago. I've been talking about developmental plasticity, but there is something called adult plasticity, and that's really what you're talking about. So there are different mechanisms. Adult plasticity typically takes advantage of existing neural substrate and sort of brings it to bear on a new problem. Recovery from stroke would be an example, or recovery from a brain injury would be an example. That's different than developmental plasticity, which basically involves the original recruitment of new neural connections, rather than, if you learn anything while you're at this meeting, you'll have made new neural connections. So clearly your brain is still plastic. That's lifelong or adult plasticity. So mindfulness, exercise, things like that are all the rage right now, and I'm going to come back to that in just a minute, depend really on adult plasticity. I am not an expert in this literature, but in this course I'm teaching now, we have one lecture on cognitive brain training. Exercise right now is the only thing that we know to protect the brain and to slow cognitive decline. Whether mindfulness, meditation, things like that work for everybody is a whole different issue. Training like luminosity and others, the extent to which these things generalize to other things isn't clear. But exercise has overall effects, and we know biologically why that is. You can make new capillaries, you increase blood flow, it increases the rate of the birth of new neurons in certain parts of the brain. Okay, so the point here is that different neural and behavioral systems are affected differently by different types of adversity at different developmental time points. And I know I use the word differently many times here, but the point is that not all domains are the same. So language and cognition and the like depend on experiences at different points in time and different types of experiences. So as a rule, early adversity has a more profound and longer-lasting consequence than later adversity. So if you have the essential building blocks in place, your brain tends to deal better when confronted with adversity later in life than if you start life facing adversity before your brain has had a chance to develop in a more typical fashion. So the next bunch of slides come from a very well-known study called the ACE study, the Adverse Childhood Experiences Study, which was done in Southern California. It's a retrospective correlational study. Basically, you ask a bunch of 50-year-olds about adverse experiences they had when they were young, and what they do is they relate the number and type of adverse experiences to later development. The themes are, it's the number of adverse experiences, not any given adverse experience, and the age at which they occur that most influences outcome. So this is children on the y-axis, children with developmental delays. And you can see that as the number of risk factors increases, so too does the percentage of kids with developmental delays, such that kids with 7 risk factors, most such children will wind up with some kind of a developmental delay. What are categories of adverse childhood experiences, right? When I talk about 7 or more, well, this is what we're talking about. Abuse. It can be emotional abuse, physical abuse, sexual abuse. It can be neglect, emotional neglect, physical neglect. It can be household dysfunction, mother treated violently. I also work in Brazil where I learned that there's a very high level of family violence, but it turns out it's bidirectional. Moms beat up husbands as often as husbands beat up wives. In the U.S., it tends to be mothers being treated violently. Household substance abuse, household mental illness, parental separation or divorce, household member in jail. So what are some of the effects of early childhood experiences? So what I'm going to plot now are the risk factors for adult substance abuse as a function of the number of early adversities confronting children. So the x-axis is the number of adverse events. The left side is alcoholism, the right side is illicit drug use. And as you can see here, as you move up as the number of early adverse events increases, so too does the risk of developing alcoholism or a problem with illicit drugs. So that on the left side, individuals who endorse 4 or more adverse life events, 16% of them will wind up with an alcohol problem. Those who have 5 or more adverse life events, 40 to 50% will wind up with an illicit drug problem. What about heart disease? Odds ratios on the y-axis simply means the odds are X. So if the odds are 1.5, it just means the chance is 1.5 times greater than to be expected by chance. You can see again, as you move to 7 and 8, that those individuals with 7 or 8 early life events have 3 times the risk of developing adult cardiovascular disease. So this is not simply the sequelae, the psychological sequelae of early adversity. It's also how it affects our physical health. So exposure to toxic stress during a sensitive period of development, generally the first few years of life, can have a profound impact on child and adult brain, behavioral, and biological development. So let's not think that exposure to early adversity can only affect the psychological makeup of the child and the adult. It can also affect their biological makeup. The greater the number of adverse experiences the child is exposed to, the greater the risk of compromised development. Now, if you're like most people, many of you are probably sitting around thinking about how many early life events you had. And I'm in this group that's an offshoot of our Center on the Developing Child. And after one very long meeting where the ACE study was presented, I went to the bar, and there were 7 colleagues, and they were having a contest who had the highest ACE score. And of course, they were all professors, and they were all competing with one another for having a higher ACE score. But they had all seemed to overcome that adversity. Before I turn my attention to profound deprivation and neglect, which is how I'll sort of close things out, any questions about toxic stress? Back there. If those events are buffered by supportive relationship, they may fall into the tolerable stress category. If, on the other hand, there's no supportive relationship there, then they would fall into they could fall into the toxic stress category. It all depends on the extent to which the child has someone to help interpret the world for them, or not. Right, so let me, to restate the question, and correct me if I'm wrong, can a child who experiences, say, 3 or 4 forms of adversity, if that occurs in the context of a supportive or a buffering relationship, can you minimize the long-term consequences? Is that a fair? And the answer is yes, but. Here's the but. There can be built into this a contradiction, which is if you have 4 early adverse life events, if some of those tend to be parents who have a mental health problem or a substance use problem, you may not have a buffering relationship. But here's where it's a straightforward yes. One of the, I work with a lot of undergraduates. Besides teaching them, I have a lot of my labs. So I've gotten to know a lot of Harvard undergraduates. And Harvard has been very good at admitting students who are born into risky families. And to a student, when you talk to them, there was always someone there for them. It could have been often it's a teacher for these students. It could be a teacher. It could be a grandparent, an aunt, or an uncle. If it wasn't the parents, but there was always it could be an older sibling, but there was always someone looking out for this child, despite the adversity that they dealt with. So that's why I'm saying yes. But if they do have that, then yes, you can overcome that. But if they don't have that, then you have to start to worry.
What you're describing, does this sort of overlap a bit with attachment theory?
What is with the attachment thing? I just spent 5 days with Charlie Zena, who's a colleague of mine in the work I'm about to present, who's the world's attachment expert, and all he talks about is attachment. So when I talk about a supportive buffering relationships, what I'm really saying in code is someone you have a strong attachment to. someone who's looked at, who's made an investment in you, which is exactly the opposite about what I'm about to talk about. So does that help? And does it help you? So you've worked through your attachment issues for now, and we can move on? All right. So hold on. So to be a little less glib about this, the way we think of this is that before the child has the cognitive ability to regulate their stress system, to make sense of the world, they need somebody to help them do that. A common example. So I fly a lot, and I like to fly. If we hit a really bad patch of rough air, and you know, you're thinking the plane's going to go down, the first thing I do is I look at the flight attendants. And the flight attendants are just blasé about this, and I think this is just common, and I'm fine. If they're panicked, then I panic. But I know how to modulate my stress response by doing that. Little kids sometimes don't have that. So if they have a relationship with another person, it doesn't always have to be an adult, but it's commonly an adult, that person helps them make sense of the world. And that's what we're talking about. Call it an attachment or call it a relationship, you know, it's a little of this or a little of that. There was one more and then I should go on. Yeah. Yes and no. That is, I can't speak to it as an immunologist because I'm not, but I can tell you the data are pretty compelling. We know that exposure to chronic and severe stress can lead to a dysregulation in the immune system, and that can have permanent effects. Well, I say permanent, meaning it can have long-term effects. How that works is not clear to me. That is, it's clear to immunologists, but it's not clear to me. The bigger issue is why do we see it more often in women than in men? You know, we have similar immune systems as a species, but there's a differential effect on males and females, and that's what I think I certainly don't understand. But there's a literature out there that you can find, and there is certainly an association between compromised immune function and early stress exposure. Okay, so now I want to turn to an even more depressing topic than toxic stress, which is what happens if you're profoundly neglected early in life. So let me put this in a broad context. UNICEF estimates that there's about 130 million orphans around the world, and a conservative estimate is 8 million live in institutions. We know that there are also millions more who experience profound violations of the expectable environment, often characterized by profound neglect. So the question is, what are the effects of profound deprivation on brain and behavioral development? This has been looked at in animal models for decades and decades, but the question for those of us interested in the human is what happens when children are exposed to profound neglect early in life. And I'm going to talk about a project that two colleagues and I have been doing in Romania for the last 15 years, the Bucharest Early Intervention Project, which we think is a model system for understanding how neglect impacts development. So this is a randomized controlled trial of foster care as an intervention for the social deprivation associated with institutionalization. We studied 3 groups of kids. And the reason I'm talking about this is, again, it's a model system. And I think the lessons we've learned from this study generalize to many, many other circumstances. We studied a large group of children who were abandoned close to the time of birth and then placed and raised in an orphanage or an institution. Same group, except after they were placed in the institution, we took them out and put them into foster care that we built. And then children who've never been in an institution who grew up with their biological family. So 136 kids, all of whom were abandoned, placed in institutions. We do an extensive baseline assessment on them. Half get randomly assigned to foster care that we had to build ourselves and maintain. Half randomly assigned to remain in the institution. We could do this because we could only identify 68 families that would be good foster care families. So we put 58 kids in those families. We put 68 kids in those. I'll start this one more time. We had 58 families, but we put 68 kids in the 58 families because we kept siblings together. Okay, I got there eventually. So then we wind up following this cohort for a long period of time. The kids who start life in the institution and then pretty much remain. Kids who start life in an institution go to foster care. Kids who live with their biological families. Following the baseline assessment, when kids were on average about 21 months of age, we saw the kids again at 9, 18, 30, 42 months of age, 54 months of age, 8 years of age, 12 years of age, and we're just now starting a 15-year follow-up of these kids. That's what I was doing there this week. The findings I'm going to present to you involve what's called an intent-to-treat design. So here's what I mean. If you're doing a clinical trial, let's say I'm doing a drug trial for diabetes. Everyone in the room has diabetes. This half I assign to this new drug. This half you just get whatever you've been doing all this time. And over time, there could be changes in your group assignment. So you guys, which are using, the standard of care that you've always had, maybe you start taking another drug, or you start exercising more. Or you guys start with the drug, but because you don't like the side effects, you stop the drug. But intent to treat means I analyze the data based on your original group assignment. Now here's why that's important. In our case, we started with 68 kids in the institutional group, but we had an ethical requirement that if kids could change their group assignment, they could. We wouldn't prevent that. As a result, some kids would be pulled from the institution by the authorities and reunited with the biological family, put in government foster care. By the time kids were 8, only 14 kids still lived in an institution of the original 68. But when I tell you the findings, it's based on where you were originally assigned. The reason for that is it preserves the virtues of randomization. Otherwise, I have sample bias. An example, a very famous study done of adoption in the 1960s, when you study kids who come out of institutions, you want to know who gets to leave an institution. So in that study, redheads never got adopted. So leaving aside the obvious of kids with special needs who don't get adopted, it could be as benign as having red hair. All right? So that's sample bias. We don't have sample bias because we did random assignment. But it also means our effects are very conservative because it really reflects where the majority of kids spent the first few years of life, not where they subsequently spent their life. Is that clear? Okay. So, why is institutionalization bad? Insensitive care, so regimented daily schedule, non-individualized care, isolation, no response to distress or aggression, lack of psychological investment by caregivers. I can't underscore the importance of this enough. Unlike an adoptive parent or even a foster care parent, these are caregivers who make no investment at all in the children. There can be rotating shifts, high child to caregiver ratios. So in our case, we tended to have 12 to 14 kids for every one caregiver, except at night when there'd only be one caregiver for, say, 40 or 50 kids. So we think of this as general profound neglect because, from the beginning, kids were deprived of most things. They would lie on their back in a crib staring at a white ceiling, and they stayed like that for the first year or year and a half of life. So they had no visual experience, no one talked to them. It's often eerily quiet in institutions because kids learn not to cry because no one pays attention to you if you cry. When you finally start having locomotor ability, it's constrained to where you actually can go. You don't have a lot of experience to practice. So the hypothesis under the study then was that deficits and developmental delays that result from institutional rearing will have their origins in compromised brain development. And the reasons go back to what I said in the beginning. Certain experiences that were expected to occur during sensitive periods of development fail to occur. And the result is the brain doesn't wire correctly, or it doesn't wire, in the case may be. So some domains of function are more experience dependent than others. And so for those that are experience dependent, the timing of the experience will vary by the domain, so that the efficacy of foster care will vary by domain, by age of placement, and by duration of time. Okay, so the translation. How old you are when you're placed in foster care will have it determine whether you show cognitive recovery, linguistic recovery in different aspects of brain development. So you'll see that I talk a lot about age of placement, and that's the sensitive period hypothesis. Classic view of institutions. These happen to be in Romania. I've seen institutions in many places in the world. They're not so different. How many of you have ever been to an orphanage? Just a few of you. Was it anything like this or not? Because some, like I've been to orphanages in Brazil that really look pretty cool. They look like a good daycare center, except there's still 50 kids for 2 or 3 caregivers. So you can see the kind of deprivation we're talking about here. I'm going to skip this because I realize I need to stop in 5 or 10 minutes. So I'm going to go through some of the key findings. I'll start with IQ, then move to brain. At baseline, before the kids get randomly assigned, they're all in the institution. The green represents the kids in the community who've never been in an institution, and the red represents the kids in the institution. And 100 is the population mean for IQ. You can see that the kids in the institution are right where you expect, the kids in the community are right where you'd expect them at 103. Look at the IQ of the kids in the institution. It's 64. Those of you who work with special needs kids know that 64 is well into the range of what we historically would call mental retardation. Now, let's look at the intervention effects. If you look at IQ as a function of age at entry into foster care, so this is only the foster care group, you can see this dramatic shift that kids placed after 24 months of age have IQs that are in the mid-70s that are the same as the kids who've never left the institution. Whereas kids placed before 2 have markedly higher IQs, demonstrating that there's a sensitive period for intelligence. Placement before 2 leads to a much higher IQ than placement after 2. This is a little complicated. Let me see if I can summarize it this way. I'll do it this way. This is at 12 years of age. Remember, there's only 14 kids who still live in an institution at 12 years of age. And this is going through different subtests. But if you just look at the full scale, the far right, where it says full IQ, you can see that it's about 100 for the kids in the community. And it's higher for the kids in foster care than the kids in the institutional group. Not a lot higher, but 4 or 5 points higher is still a big difference. So, if we look at percent time in an institution as correlated with EIG stands for ever institutionalized, we can see for full-scale IQ, for verbal, for perceptual, for working memory, for processing speed, and except for the last one, in every case, the longer the child spent in the institution, the lower their scores on all of this. So there's this point of diminishing return. The longer kids spend in these environments, the more of a hit they take on their cognitive development. Okay, for you two, attachment. Do you understand the concept of attachment generally, and that you can have a secure attachment and an insecure attachment? So if you look here, this is just the foster care data. If you look at the percent of securely attached kids as a function of age at placement, you'll notice that kids placed in the first 24 months, that 60 to 80% have a secure attachment. Kids placed after 24 months, 30% have a secure attachment. There's a huge effect on attachment. Placement before 2 leads to a much greater likelihood, probably 3 times, of having a secure attachment. Now, a rather insidious form of an attachment problem is sometimes referred to as indiscriminate social behavior. It's characterized often by kids who will walk up to you. You're a complete stranger. They'll sit in your lap, hold your hand, walk off with you. This is very difficult to get rid of. You see this persisting through adolescence often in these kids.
Is that reactive attachment?
No, I'm getting to reactive attachment disorder. Just be patient. Here I was thinking I was talking to neuroscientists. Here's reactive attachment disorder. So there's 2 types. There's emotionally withdrawn and inhibited. These are kids who look, it's quite scary to look at. These kids will freeze when confronted with, say, a stranger. The indiscriminate or socially disinhibited, on the other hand, will walk up to a complete stranger. If you look at the withdrawn, depressed type over the first 8 years of life, this is based on caregiver report, you'll see, here it is. Down here is the prevalence among the community sample. There's 1 kid like this. There's really, there's nothing at all. The black circles that drop, those are the kids in foster care. And it shows that by 30 months, these kids have almost gotten rid of their, this sort of withdrawn type. But the CAU stands for care as usual, the institutionalized group. You can see it remains elevated all the way through 8 years of age. So placement in foster care dramatically reduced the prevalence of this withdrawn type. But that's different than the indiscriminate type that I just illustrated. Now, if you look here, you'll see the black in the middle, the black circles. Those are the kids in the foster care group. And they're getting better, but they never look as good as the kids who've never been in an institution, suggesting that even at 8 years, this is persistent. But if you look at it based on dividing the sample by when they were placed, the lower curve is the kids placed before 24 months. The higher curve are the kids placed after 24 months. So for IQ and for attachment, and I'm skipping over some other things, we see a sensitive period that hovers at around the age of 24 months. So attachment is profoundly compromised in institutionalized kids. Foster care ameliorates some of these attachment disturbances. Earlier foster care is disproportionately more effective. Let's look at social skills. Now, you're my time. Well, you're not my timekeeper, but you're sort of my boss. When I have 10 more minutes, but we want to leave time for questions. Okay. So we looked at social skills in many different ways, but back to you attachment aficionados, we assume that if children have had bad attachment relationships, that's their model for how you interact with people. So we expected kids with poor attachment relationships to also be bad at interpersonal relationships. So this first pass was simply, do the kids in the care as usual group versus foster care versus never institutionalized differ in how their teachers rate them in terms of social skills? We actually have a whole battery of things that we actually do directly to observe this, but I'm only going to present the teacher ratings because I know that many of you are teachers. If you look here, this here is telling us, I'll start here. For the never institutionalized group, the teachers rate 70% of those kids is very high in social skills. And this curve, this line here, are the kids placed before 24 months of age, and they're not different. But now look at this. The kids placed after 24 months of age look no different than the kids who are in the institutional group. So again, we see this cut point at around 2, where kids placed before that are rated as having social skills not that different than kids who've never been in an institution. But after that, the teachers rate them as having social skills similar to kids who've never left the institution. All right, I'm going to do EEG and then I'm going to stop, even though I have another hour's worth of material. EEG just reflects the summation of the brain's electrical activity. We can record it by placing these sensors on the head. It's a crude metric of brain development. And one way to illustrate this is you can create what are called false correlate maps, which means that as you move to the red spectrum, from say blue to red, it illustrates the amount of brain activity. So the top at baseline are the institutionalized kids, and the bottom represent the never institutionalized kids. You're looking at from the top down, and this is the nose, back of the head, left ear, right ear. So this is the view from the top down. Notice how much red there is over the frontal lobes in the never institutionalized group compared to the institutionalized group. So the brain is dramatically underpowered at baseline. If you look at it at 8 years, this is an amazing effect. The top left are the care as usual kids assigned to the institutional group. And next to it on the right are the kids placed in foster care after 24 months of age, and they're identical. The lower left are the kids placed in foster care before 24 months of age, next to the never institutionalized kids, and they're identical. So we fully remediate EEG by placement before 24 months of age. And the last thing, is we did MRIs on the kids, and we see good news and bad news. Gray matter refers to things like dendrites and cell bodies, and white matter refers to things like myelinated axons. For gray matter, when the kids are 8 to 10, we see no intervention effect at all, that the kids show a dramatic reduction in gray matter. For white matter, we see a bit of an increase in the foster care kids. That is, kids in foster care have a little bit more white matter than the kids in the institutional group, but less than the kids in the never institutionalized group. So here's an example where the intervention was differentially effective on the two different types of gray matter. So I'm going to skip over all of this. Exposure to institutionalization early in life has a differential effect on gray and white matter. We also show, those are the slides I just skipped, that when we look at what's called diffusion tensor imaging. We look at actually the integrity of white matter fibers. The integrity of those fibers is reduced in the institutional group. There's an intervention effect for some fibers but not others. Those fibers are the communication pathway in the brain. It's how different parts of the brain communicate. So not surprisingly, we're finding a sort of a reduction in the integrity of those pathways by institutional rearing. So the effects of adversity can have both proximal and distal effects on development. I've talked about various forms of toxic stress and neglect. And it can affect locally on child development, and it can affect distally on adult development. We have to pay particular attention to the timing of these effects, as experiences occurring during a sensitive period may prove to be particularly egregious, or in some cases, not occurring during the sensitive period. The future is the ability to rescue critical periods may prove instrumental in developing new treatment options for kids growing up in adverse circumstances. So when I was in Romania the other day and I visited an institution for teenagers, and I look at these kids, I think, is there anything we can do at their age? And that's the big unknown for us right now. And that's it. I'll stop there and we can have time for some questions. Thank you. Oh, hold it. You're supposed to. She's going to give you a microphone.
The foster care program that you developed,
Yeah.
I am assuming has certain standards that it must meet, so that it's not like our foster care system here in America that
Correct.
can be really crappy.
Lower quality.
Poor quality, crappy. Therefore, out of your study might also come some guidelines?
Yes. So Charlie Zena really developed a very, very high quality foster care system. So briefly, all the parents had to be licensed. They could have only one kid in their home unless there was an exception for like having siblings. One parent had to stay home. We provided all material support, diapers, toys, 24-hour on-call pediatrician. We had social workers visit the families every 10 days, and every 7 days the social workers met with us to troubleshoot problems. Families were having problems. We did an intervention. So this was, the Cadillac, the Lexus of foster care. I should say that at 54 months, the intervention ended, and we've just been following up. But almost half of the families we recruited as foster care families still have their kids, and a third of them adopted them. So the implications here are, in fact, what's sad is that Charlie has tried to import what he developed in Romania into New Orleans, which says something about the status of foster care in New Orleans.
All right, so is this on?
Yeah.
No, okay, there we go. So my question isn't about the same kind of traumatic stress, but because we know that different adversities can affect our neural network, what do we know about early chronic ear infections affecting the language neural network? Because there seems to be a correlation between, at least for some kids, early chronic ear infections and language development, even if they get tubes in their ears. And I know I've read some research from the 70s, but I haven't seen a lot of.
Yeah, so I have to say that I'm not up to date on the literature, but historically, it was shown that kids with chronic otitis media, in fact, were at an elevated risk for having speech and language delays and disorders. But it's, I think, a function of their hearing. So if they have tubes, for example, if they're treated and their hearing is fine, then there's no correlation at all. It's the chronic diminution in hearing function that correlates with language outcome. I think that finding has still held up, but I'm not positive.
I wanted to ask, did this go through an IRB to balance out the issues of keeping children in an institution versus giving what sort of common sense would say is a more enriching environment?
Right. So there was a very tiny footnote that said, I'm happy to talk about the ethics of this study. The brief answer is not only did it go through an IRB, it went through 4 IRBs. It had to be approved by 3 U.S. universities. It had to be approved by an IRB in Romania as well. This study has been extensively written on just the ethics. Editorials have appeared in both Science and Nature. We have written papers about this. This is a big issue. And I can tell you that, what I should tell you is that we spent a year discussing the ethics of this before we launched this study. So I'm happy to go on at length about all the ethical requirements in here. But let me just touch on that last one, because maybe what I said earlier I didn't say it correctly. We did not withhold care. There was no foster care in Bucharest when we started, so we had to build our own. And one reason there was no history was in the communist system, the assumption was that the only people who would take a child into their home who wasn't related to them biologically was a pedophile. So we had to do extensive advertising and then screening, and all we could come up with were those 58 families that we thought would be good foster care families, and that's when we placed the 68 kids. The policy of non-interference meant that kids would change group assignment as time went by, so we weren't withholding treatment there. Those are the two big things. But in that book, and I can send you papers, we have long, boring papers written just describing the ethics of the study. Sure. This probably needs to be our last question.
Yes.
Yeah.
Yes, this will be our last.
In your study, did you have any interest in the dietary situation of the children in the institution?
To restate the question in case you didn't hear it, did we pay any attention to the nutritional status of the kids? And what he didn't ask, but I think he's thinking, is can any of our findings be accounted for by nutrition? And this is one of several serious shortcomings in the study. We had no information about their prenatal diet or prenatal life, and we did not keep track of the nutrition in the environment, except we did measure growth. We have growth data on everybody. But we recently got the menus that were available to the kids when they were little, and we had a dietitian look at them. It turns out that the diets are not great, and there's certainly micronutrient deficiencies we can expect, like iron, but the kids were not malnourished. The failure to grow, though, is probably due to what's called psychosocial dwarfism, and this is common in neglect situations. So it's not uncommon to see 15-year-olds who are only this tall, because you lose 1 month of linear growth for about every month of growth. So we really wish we had looked at nutrition, and if we did it again, we would, but we don't think nutrition can account for the findings. It's a good question, though. Thank you very much.
Yes, and thank you so much.